I think we're rolling here. All right, so we got 5.1 here today. The front of this page here, we're going to be going through some of the important identities that we're going to be using here for pretty much the entire unit. Your quiz tomorrow is going to be over everything here in this gray box. Looks intimidating at first, but some of them we already kind of know, so it'll speed it up here. If you want up here in the top, this an equation is an identity. If the left side is equal to the right side for all values of the variable. Okay, so we have a couple of them. The first few of the identities that we'll look at here is the reciprocal identities. Okay, the reciprocal identities you already know. Okay, what's the reciprocal function for sine? Remember that? Not cosine. Cosecant, yeah, good thinking. So we're going to say that sine of theta is the same thing as 1 over cosecant of theta. Y'all kind of already knew that those were reciprocals from the last 2 units. Okay, so by that same argument, what about cosine? 1 over secant, good, of theta. And then what about tangent? 1 over cotangent, good. Okay. So that's that there. Let me see if I can make this full screen. No. Yeah, there we go. Well, I guess I didn't make it that much bigger. But okay. All right, so what about cosecant? Cosecant's the same thing as 1 over what? There we go. What about secant? Yep, 1 over cosine of theta, good. And then cotangent. 1 over tangent of theta. There we go. So those you already I guess, kind of knew. The quotient identities coming up here. Do y'all remember, like on the unit circle, tangent was always what over what value? Okay, so I'm going to write it off to the side. That's not what we put in the blanks here, but we'll use that to help ourselves. What was y always tied to on the unit circle? Okay, so we're going to put sine of theta, and then over what? Yeah, so kind of using that same idea of x being on the bottom. Tangent's also the same thing as sine over cosine, so it's a little bit different than the reciprocal identity. This is one of the quotient identities. And you can also do that with cotangent. What do y'all think cotangent might be? Yeah, you flip it, cosine over sine of theta. So those are your quotient identities right there. So those right there actually make up a good chunk of the points on your quiz here. The reciprocal identities are going to be 8 points each. So there's 6 of them there, 6 times 8, 48 points right there. That's easy. All right, so hopefully that takes a little bit of stress off you guys. Y'all should already know those. Your quotient identities are also going to be 8 points there. So there's 16 more right there. So right then and there, I don't feel like that most of y'all are going to struggle there with those. Those should be not too bad. The next coming up here are the Pythagorean identities. All right. If you know the first and main one, you can go get the other ones fairly easy after that. So this is a real important one right here. The Pythagorean identity, I'm going to write sine squared of theta like that. By the way, we don't put the squared, we don't put it after the theta because some people think that means the theta is the squared part, where really it's the entire sine piece is squared. So usually they'll put the squared right after the letters SIN there. So I'll go sine squared of theta, and then plus cosine squared of theta, and it equals 1 actually. If you're to go kind of look at the unit circle, the hypotenuse is generally 1, and then the sine is kind of the part going up and down, and the cosine is the part going left and right. And that's your main Pythagorean identity. Memorize that one right there. Okay? Now, off to the side here, I'm going to go rewrite that same thing, and I'm going to show you where these other variations come from. So go off to the side here, maybe kind of near here, and write sine squared of theta plus cosine squared of theta, and then equals 1. And then to get one of the other variations, take all of that and divide each term by sine squared. This will kind of simplify down to something that's a little bit different. What is sine squared over sine squared? What would that simplify to? I think I heard it. 1. Good. Now, look up above. We said cosine over sine was equal to what by the quotient identity? That's cotangent. So if you have it squared, it's going to be cotangent squared here instead. And then using a reciprocal identity, what is 1 over sine the same thing as? Cosecant. So 1 over sine squared would be cosecant squared of theta. And that's going to be one of these variations to one of your Pythagorean identities. I'm going to go ahead and copy it down over here, this top line. So what did I divide by to get that? You divide everything by sine squared. Okay, back when I learned this, I don't think anyone taught me that. I just memorized 1 plus cotangent squared is equal to cosecant squared. But if you memorize that, you just divide by sine squared. You can go get that pretty easy if you know your other properties. You could memorize it if you want, but sometimes people kind of get things in the wrong place. So that's where it comes from. Next, I want y'all to go and rewrite sine squared theta. I'm going to write it to the right again. Sine squared theta plus cosine squared theta. And then equals 1. And this time I'm going to divide by something else. Any ideas what we might go back and divide by here instead of sine squared? You're actually going to divide by cosine squared. Yep. And when you do that, you're going to get something. I'm just going to go ahead and write it down in the blank down below there. Sine over cosine is what, according to one of the quotient identities, if you zoom out? What is sine over cosine? Yeah, that's going to be tangent, yep. So we'll say it's tangent squared. What about cosine over cosine? What would that come out to? Or yeah, plus 1, I heard. And then, yeah, the next part will be 1 over cosine squared will be equal to secant squared. Just like that right there. So these 3, let me zoom out here a little bit, those 3 are kind of the main Pythagorean identities. These other variations you're not going to fill in on the quiz, but basically we're going to rearrange all of these here. So if you know these 3 right here, these 3 are going to be 8 points each right there for 3 of them. Okay, so I would, on this, like on your notes there, I'd probably highlight, wow, that was weird. Let's try it again. Let's make a rectangle. Okay, well, anyways, there, I would highlight those. Those are the main ones that you need to know. Any follow-up questions there on those? Okay, so let me go back down to sine squared plus cosine squared equals 1. The variations, like sometimes you'll need to rearrange them for some of the examples we'll see here in just a moment. So if I were to get sine squared by itself, what would you need to do with cosine squared? Yeah, subtract. You just 1 minus cosine squared theta, like that right there. And what about if I wanted to get cosine squared by itself? What would you need to do? Yep, subtract sine. So these are just the same thing, just rearranged differently. So that's all. So don't worry about memorizing the ones down below. Just know the main one up there at the top, and you'll be okay. Okay. Over here, with this red one here, with the cotangent cosecant squared, we can rearrange this here. Like, for example, if you want to get cotangent squared by itself, you could go and do this here. You could go 1, or actually, I'm sorry, it'd be cosecant squared, and then minus 1 like that. And then what about it? You could actually get 1 by itself. What would you need to do if you want 1 by itself? Subtract what? Yep. So cosecant squared theta minus cotangent squared theta. So same thing, just rearranging. And then finally, over here you got the tangent squared of theta plus 1 equals secant squared of theta right there. So let's rearrange those. Let's get tangent squared by itself. What would that look like? Yeah, subtract 1. That would be secant squared theta minus 1. And then if you want to get 1 by itself, subtract over tangent squared. It would look like this. So let me zoom out here a little bit, make sure you got all of those. And honestly, even if you don't have the variations, as long as you have these right here, that's all that matters. That's all you're going to need to fill in on your quiz there, the highlighted ones there. So I think if you get all of those right there, I think you're at an 88. So there are, I think, 12 other ones here. These ones down here below the cofunction and the even and odd identities, we don't really use these as often. I think we use I think we use them a little bit today, and then I think like maybe once or twice throughout the rest of the unit, but not as much. So these are the main ones. These are the most important ones that you guys have right here. So the co-function identities here, the big idea with co-function, I'll draw this triangle up here that I have on the board. The big idea is if this angle is 40 degrees right here, and I do sine of 40 degrees, that's going to equal to, let's call them like side M and N right there. That's going to be, oh, and then I guess I'll put H up here. That's going to be M over H for the sine function. And if I go find the other angle up there at the top, what would we need to do for that? Yeah, add 90 and 40, subtract from 180, and then it kind of works out too where it's like 90 minus 40, you would get 50. And I guess the big idea here is cosine of 50 degrees actually is the same exact fraction. So what that means here is sine of an angle is the same exact thing as cosine of that angle after subtracting it from 90, or usually we'll write it in terms of pi over 2. So 90 minus your angle, and then doing cosine of that, that's the same thing as sine. That's called a co-function identity. We call it a co-function identity because it's sine and cosine right there. One's with co, one's without co. And you can do the reverse order here. You can do cosine of an angle is the same thing as sine of pi over 2 or 90 minus the angle. Most of the times I want to see pi over 2. And that will work with cosine, that will work with tangent as well. Or not cosine, cosecant and secant, I guess I should say. So let's go write that off to the side. You can do this with secant. Secant of an angle is the same exact thing as cosecant of that angle subtracted from pi over 2. Has anyone got the next one down below? It's kind of the same thing, but in a different order.
Cosecant equals secant 2 pi.
Yep. And then, so cosecant of theta is equal to secant of pi over 2 minus theta, like that. And what do y'all think the last line's going to have? Probably going to have tangent and cotangent. Yep. So these are all kind of similar. You just got to figure out which ones kind of go with each other. So that's tangent is equal to cotangent of pi over 2 minus theta, and then cotangent is equal to tangent of pi over 2 minus theta. There's one problem, I think, that, or actually there's two that we use that idea. So that's a co-function. Co-function because it's cosine and sine, basically. Okay. This last section here is dealing with taking the sine or cosine or really any trig function of negative angles here. So let me actually kind of cue us up here. What I want y'all to write down below is I'm going to write sine of negative theta equals, and then I'll do the reciprocal ones down below those. So that'd be cosecant of negative theta is equal to something. So I'm going to basically do that for all the trig functions. Let's do sine, cosine, and tangent in the top. This is secant down here. And then we're going to say what they're equal to here in a second. Tangent of negative theta, and then cotangent. Okay. So depending on which function you're dealing with here, some of them will be even, and then some will be yeah. If you're, grab it here real quick. Is there one on there? Oh yeah, there you go. Sorry about that. All right, so certain ones of these, actually the negative comes out. I'll show you how here in a second. So like sine, the negative can come out. And same thing with cosecant, the negative can come out there. And that's because these are odd functions. I'll show you visually why that is in just a second. But those are both odd functions if you were to look at the graph. When you deal with even functions, like cosine and secant right here, because they're even, it actually makes the negative go away. So actually cosine of a negative angle is equal to cosine of a positive angle. Same thing with secant. And that's because the functions are even, and I'll draw it out here in just a second. Well, actually, here, we might as well talk about it now. If you go look at a cosine graph, normally, y'all are kind of used to saying it is like that. Now, if you do cosine of a negative angle, like on the other side, like let's say like cosine like right here, that y value would match with this y value over here on the other side, which basically means if you do cosine of the negative version of the angle, you'll get the same y values if you do cosine of the positive version of the angle. So the output's the same. And that only happens with cosine and then secant. With sine, if you go back and kind of look at the graph of sine, sine is an origin rotation or an odd function. So when you go like backwards, they'll have different y values. One of them will be negative y value, and one of them will be a positive y value. And you don't necessarily need to know that. You just need to know which ones the negative comes out of. And the only ones that the negative will come out of is sine and cosecant, and then also tangent, the negative will come out. And then also cotangent, the negative will come out. So the only ones that don't are cosine and secant. We don't, I think we use that property like once or twice, like today, and then I don't think we really use that property a ton after today's. So that is the list right there. So a little bit of memorization as far as like formatting goes on the co-function identities and the even and odd. You got to memorize which ones the negatives come out or not. But these are all going to be worth 1 point a pop right here. So if you add them up, I think that's only 12 of them there. So it's not the end of the world if you miss those. It's not heavily covered. I'm more concerned is on if you guys have the top here of this. Now, what I would do, since hopefully you got them all filled in now, is I would probably take a picture of that on your phone or somewhere where it's like you can pull it out real quick and easy while you're doing your homework, because this will help with some of the homework stuff that we'll do today. So feel free to if you want to take a picture of the screen as well. Okay, and then we'll start doing some examples here. So the first couple of examples are actually going to be very similar to some of the examples that we've seen in the past. We can use a couple of our reciprocal identities to help some of these here. But these three examples coming up here are where you just draw a triangle in the correct quadrant and then find the correct ratio that they're asking for. So like on this first one here, you have cosecant of theta is equal to 7 over 4. We don't need to draw any triangles here for this. How would I find sine? You'd flip it. Good idea. So yeah, sine is the reciprocal of cosecant. So you could just take this and flip the fraction. And I think there's one like that on your homework where it's literally that quick and easy there. Takes you 2 seconds to write out. Not all of them are going to be like that, but there's one kind of like that. Nice and easy. Now, sometimes you'll get ones that look like these. These are kind of the problems where you got to figure out what quadrant these are going to be located in. There are ways to use your properties that we just learned, like the Pythagorean identities. I think you can use a little bit to go find some of these, but I still find it's easier just to draw the triangles out. So that's usually the way I teach it there. If you go to like a different teacher's class, they might use some of the properties. I know Ms. McDaniel's video online goes through some of the properties, but I like the triangle method, so I think it's the most efficient. If secant of x, by the way, is 5 over 4, that means cosine of x is what?
4 over 5.
So you flip it, 4 over 5, right? Now, so that's cosine and secant is positive, and then tangent is also positive. If you do the little all students take calculus trick to figure out which quadrants things are positive in, you should be able to narrow it down to one of the certain quadrants. What quadrant is both cosine and tangent both positive in? The first quadrant up there in the top right. Yep. A stands for all trig functions positive. So yeah, I'll draw my triangle there. X is the angle. Normally we use theta. Sometimes we'll swap it out with x, but it's the angle here. And then we can go and label the triangle. Cosine is the adjacent side over the hypotenuse. What's the opposite side? Yeah, it's a 3, 4, 5 triangle. You can even look at the tangent ratio and also see that that's 3. So then if I want to find sine, the sine ratio, that would equal what over what? Yep, 3 and then over 5 right there. Opposite over adjacent. So a little triangle problem, not too much going on there on Okay. So the next one, we'll have to be a little bit more careful on the quadrant location for this next one. This actually kind of looks like from the chapter 4 part 1 stuff that we did, and actually I think that was on your chapter 4 part 2 test. It's one of those review questions like this at the very end. So looking at this one here, we'll make, I guess, a little quadrant here. X and y axis. And by the way, if tangent of theta is -8, how do you rewrite that as a fraction? Yep. Now I'm going to specifically write it this way. I don't know technically where that negative goes, if it goes with the negative, if it goes with the 8 or the 1. So I'm going to just purposely write it off to the side here, kind of right in between. So I don't know exactly where it goes. I'll have to figure out what quadrant we're in first. But we do know tangent is negative, and we also know sine is greater than 0. What does that mean if sine is greater than 0? It means it's a positive. Okay. So then let's label all students take calculus. Everything's positive in the top right, all of them. Sine's positive in the top left, tangent's positive in the bottom left, and then bottom right is cosine is positive. So if tangent is negative, that should eliminate 2 quadrants right away. Which ones? The first and the third, or the all in the tangent spot, right? Sine is positive. What does that mean? Which quadrant? It's going to have to be in that one in the up spot right there, the second quadrant. Good. So then now we know that the opposite and the adjacent are going to be 8 and 1. And based off of those locations, which of those needs to be negative? Yeah, the 1 needs to go negative because it's kind of like an ordered pair of -1, 8. Right? And that's where some people kind of messed up on that question yesterday on the test, where not having the negative with the correct spots right there. So after that, then we can go do Pythagorean theorem to go find the missing side. Just make sure you include the negative inside of a parenthesis if you're going to square it like that. It's h squared, so I think it's h is root 65 when doing that. That breaks down to 5 and 13, but you won't find any pairs, so we'll just leave it as root 65. And then from here, they want us to get the sine ratio. That would be 8 over root 65, and then after rationalizing, that'd be 8 root 65 over regular 65. And we're kind of assuming that you remember how to rationalize the denominator fairly well. What about the cosine ratio? What would it look like unsimplified?
Root 65 over 8.
Yeah, -1. Yeah, start with -1 over root 65, and then rationalize negative root 65 over regular 65 there. Those would be your ratios there. So I think that's like going to be the first couple of homework questions, just like that. Let me zoom out and make that high there for you. So any follow-up questions here so far on this? That will be the easy part here of today. So coming up here, from here on out, we're going to start using these properties to simplify things down. There will be a little bit of growing pains, but just stick with it on these here. You're going to probably have to check like the Quizlet website a couple of times this unit, so just make sure you got that to where you can pull it up really easy. Feel free to ask each other questions, ask me questions, all that type of stuff. So going on to this one here, I think there's only 1 or 2 like this in the homework here. Something like this right here. Notice that that looks like one of those cofunction identities. There's only one minor little difference. Look at your cofunctions identities on the front page. What do y'all notice? What's slightly different about this? The pi over 2 and theta are switched. There is a way to manipulate that to where we want. So I'm going to do those steps here for you here. So we need it to look like cotangent of pi over 2 minus theta. To manipulate it here, what you can do is actually swap the order, but keeping the signs with the same things here. It's negative pi over 2, and then it's also theta. We just swap the order. Okay, next after that is we're going to factor out a negative, just like this right here. We're going to factor out, oh, whoops, that should be minus theta now. So I'm undistributing a negative right there. That's kind of what's going on that. Okay, so I just undistributed a negative. Okay. Now, Here, next coming up is we're going to do one of our properties here on the previous thing. We said when we do cotangent of a negative thing, there's something that happens. So let me show you here real quick. Go back up here to this previous page. Cotangent of a negative angle, where's that? Down here. Cotangent of a negative angle, where can you move the negative? In front, right there. So that's essentially what we're going to do on this. That's because it's an that's an odd function right there. So that negative essentially is going to get moved out. Now, if it were cosine or if it were secant, the negative would just totally go away. But here, since it's cotangent, the negative will come out in front. I'll kind of keep it color-coded so we can kind of see what's happening. And then now that we have this in the order of pi over 2 minus theta right here, we can use what's called the cofunction identity here. That right there is going to be the same thing as tangent of theta. That's what that property says. So we're going to just swap that whole thing out with that. And then you're going to drop down that negative. And if you want to write this step right there, that was a cofunction identity from here to here. I want to erase that line there. I don't want y'all to think I'm dividing there. We're using the cofunction identity. Up above here from this step to this step, we use the odd identity. There. Then we're actually almost done here. Tangent of theta. They said at the beginning, I didn't read it out. What is tangent of theta theoretically right now? So drop that down, change that to 1.28, and then bring down that negative with it. This answer is negative 1.28. And that's how you manipulate the problems into what you want. Now, I'll sometimes get people where they have that on the 5-1 quiz, and they're like, oh, crap, I can't remember all the steps that we need to do. A lot of times the answer is either going to be the same exact thing, 1.28, or it might be the opposite sign, like negative 1.28. So if you forget the steps and you're like, oh, I don't know what to do, flip a coin and either choose 1.28 or negative 1.28. It'll almost always be one of those two things, the same number that you started with or a negative version of the net. And then that way you got a 50-50 chance there in case you forget the steps. So that is that type of problem. I think there's 2 on the homework tonight like that. Now coming up here on this next page, this is the kind of meat and potatoes of the lesson here. This is kind of the big stuff here. It's what y'all will struggle with a little bit. What's nice is tomorrow's lesson we'll do all the same steps that we're about to do on these here, except I tell you what the final answer is. It's called verifying trig identities. But today we got to simplify it without knowing what the answer equals to. So if you look ahead, a lot of these are going to be things with not a ton of numbers here. There might be a couple of ones and things like that, but these all simplify down to trig expressions. And this will be a little tricky at first, but we're going to be thorough with our steps. And we'll do a lot of different variations. And once you do a lot of different variations of these problems, you kind of learn how to recognize how to start these here. So the first helpful tip, there's actually going to be 5 of them if you want to leave 2 extra little bullet spaces here for room. One of the things we're going to do quite a bit is actually use a Pythagorean identity. Or sometimes you can use like even and odd. We don't use the even and odd ones a lot. Or cofunction identities. I'm just going to abbreviate that. Okay, but this is the main one. Pythagorean identities there. Like the sine squared plus cosine squared equals 1 right there. I think we use it on the very first problem eventually there. So we'll try and use those when possible. Sometimes that might not be all we need. Like if you look down below, sometimes we'll have fractions. And if you want to combine fractions, we need a common what? Mm-hmm. So yeah, we'll need to go and get some common denominators occasionally on some of these problems. Okay. Next, sometimes you might use this thing. It's called a conjugate. You use it a little bit when simplifying things with radicals back from Algebra 2. A conjugate, by the way, looks like this. If you have A plus BI, okay, just put that right there, man. This will be A minus B. All right, I said BI. I guess sometimes you use it with imaginary things. But A plus B and a minus b, those are conjugate binomials. Okay, what else we got? Oh, sometimes we might need to factor. Like sometimes we can factor or undistribute a term. And then the final thing, and this is actually a good go-to if you don't know how to start a problem. You don't always start problems with this, but it's a good go-to, is write everything with sine of theta and cosine of theta. And we'll do that using like your reciprocal and quotient identities. And that's actually the very first step that we're going to do on this first one here. So this first one here, I'm going to go ahead and spoil it for you here. This first one's actually, I think, equal to, I got written down, equal to tangent right here. That whole thing apparently simplifies the tangent. There's a lot of manipulation that we got to do. Some of the manipulation skills that we will learn here in this unit is kind of useful for some of the things y'all got to do in calculus. If you wind up taking calculus one day, you'll use some of these skills of like changing things, swapping things out. And that's why we go over this unit with you guys here. So, but anyways, it's kind of a new way of thinking here. So here's what we do on something like this. Cosecant is actually can be written with a reciprocal identity. Flip to the front page or look on your phones there of the picture. What is cosecant the same as? 1 over what? 1 over sine. Good. So we're going to rewrite that as 1 over sine of theta. By that same argument, what is secant? Yeah, secant is 1 over cosine. And then cotangent, instead of saying 1 over tangent, write it to where it's just having sine and cosine. So use one of those quotient properties. Cotangent is the same thing as what over what? Yep, that's cosine theta over sine theta. Okay, so we wrote in terms of sine and cosine right there. Next, after that, we can actually multiply the two tops and the two bottoms of these fractions here. I'm just going to write it like this: sine of theta times cosine of theta down in the bottom. Just bring down this other fraction. Or you can copy and paste it if you're on your iPad. So, okay, so next, actually, we have fractions. To combine fractions, you need a common what? Excuse me. Yeah, common denominator. Already. All right, so get a common denominator. We're going to multiply the top and bottom here by cosine. I would do it in a different color here so you can kind of see that we're putting the cosine there ourselves. Now, cosine times cosine in the top, what would that actually be? Oh, yeah, cosine squared. Excellent. So you can go ahead and do that, put cosine squared of theta, just like that. By the way, go ahead, when you see a minus in between, go ahead and put a plus there and then bring the negative up there. Let me change color so we can kind of see that we did that. So numerator is going to be cosine squared there. And then we have sine theta and cosine theta. Some people might skip writing this out and might just put it over one denominator at the beginning. So you could do that if you want. But now we have a common denominator. Since we have a common denominator, we can go ahead and put those together as 1 and then minus cosine squared of theta like that. Okay. Now after doing this step here a few times, y'all will start to recognize this here. That numerator, 1 minus cosine squared theta, when you see a 1 and then you see something squared, I want y'all to start thinking of the Pythagorean identities. Okay, so if you go back actually for a second here and look at your Pythagorean identities, what was it? It was 1 minus sine squared, I think, or was it 1 minus cosine squared? So look up here. We have one of the variations right here. What's this one right here? 1 minus cosine squared theta is the same thing as sine squared. So we're going to substitute or swap that out for that numerator. So once we'll do that step quite a few times today, you'll start kind of learning to look out for that. When you see something squared with a 1, you can go and change that to just sine squared of theta up there in the numerator like that. And then actually, we're getting pretty close to done here. And I'll write off to the side the steps we're doing there in just a second here. So what happens to the two signs? Since you have a sine squared, it's like you have two signs up in the top and one in the bottom. What do y'all think happens? You can cancel them out, actually. Yeah. So it's kind of like having x squared over x. You'll subtract the powers. You're going to have sine to the first power in the top, and then cosine down below. And what is sine over cosine the same exact thing as? According to your quotient property, that's the same thing as tangent. That's how you do those. Okay. Yeah, they're going to be tricky at first. It's going to take some time to kind of get these steps down, but the more examples you see and do on your own, the better you'll do at these. All right, let's keep it going. All right, down below. I see a pi over 2. It's not minus theta, but it's minus x. When you see something like that, you just need to think of those cofunction identities. Okay. If it's a cofunction identity, what does that change to right there? This whole thing. You can look at your properties. That whole thing should change to something right there. Yeah, that was what I was looking for there. That is the same thing as cosine of theta. I'm going to put x since they don't have theta there on that, but yep, that is cosine. Okay. Now, here is a common misconception. Some people think you can subtract the cosine from the other cosine and they cancel. You could do that if I didn't have this sine squared right here. Those would cancel each other out, but because it's being multiplied by sine squared, I should have x actually, sine squared of x. Since you have those multiply, you can't cancel those out. There is a way that you can go and manipulate this here. Treat this like two terms. You have two terms right here. Let me write this off to the side. If I had, for example, let's say y squared x minus x, what would you say both of those have in common? Over here on the right. They both have an x. You could factor out an x just like that right there. So what I'm going to do is kind of the same thing here. I'm going to factor. That's the big step here. We're going to factor out a cosine of x. I'm factoring out cosine x because they both have a cosine. Now if I divide that first entire term by cosines, the cosines would cancel and you'd have a sine squared of x left over. And then cosine x divided by cosine x would just be 1, and you have a minus in between. So that thing becomes sine squared minus 1. So I kind of told y'all to look out for this. When you see sine squared and 1, what type of identity can we use for that right there? One of your Pythagorean identities. Now be kind of careful here. Some people are going to say that's cosine squared. It's really close to cosine squared. But it's actually, look at this here. It's if you write sine squared of x plus cosine squared of x equals 1, and you rearrange it to where you have the 1 with the sine right there, you'd have to move the cosine squared to the other side. This expression here is actually not cosine squared, it's a negative cosine squared. It's got a negative with it. So just kind of got to be a little bit careful with that. Okay, so we used a Pythagorean identity right there on that. And then finally here to finish this out, you have a cosine squared x times another cosine. You would just go and add the powers. This would be cosine cubed of x with the negative with it. And that's your final answer there. That one's a little bit shorter. So kind of the big steps you need to look out for here. From here to here, we did a cofunction identity. And then from here to here, we did a Pythagorean identity. Okay. Wouldn't be an awful idea to write those off to the side, so maybe when you're looking over your notes this weekend, you kind of have them written down. Okay. All right, let's keep it going here. I'm going to do, I think, one more, and then I'm going to let you guys try out one that's not super hard. So, but let's do one more here together, and then I'll talk about that in just a second. So. Yeah, so looking here at this one looks messy here at the beginning. It'll clean up pretty well at the end. So to add or subtract fractions, you need a common what? Denominator. Excellent. So, and also, let's do this here too. When there's that negative, go ahead and bring the negative up here to the numerator right there. Start training your brain to look out through that there. Okay, and then like you guys said, yeah, we need a common denominator. So you have 1 minus sine x as one thing and then cosine x. Oh, and before I get into getting the common denominator, I had someone ask earlier today, hey, isn't 1 minus sine of x, isn't that cosine? And it's kind of close. It's 1 minus sine what? Sine squared. All right, so that looks like some people think you can use a Pythagorean identity, but you cannot do that. 1 minus sine of x is not equal to cosine x. This is not a Pythagorean identity. So be kind of careful. Now, if we can get it to where it is squared eventually, we'd be in good shape there, but unfortunately it's not. Okay, so what we're going to do here on this one is multiply this first fraction. I'm going to multiply by cosine of x. That's the other part of the denominator, and I'm going to do that to the top and bottom. The other denominator, I'm going to multiply by what instead? What's from the other denominator that we need on the right hand side? 1 minus sine of x. Okay. Now we'll start simplifying some of these down. I'm actually not going to distribute in the denominators. I'm going to keep them separate because it'll work out better if I do that. If you do cosine times sine and cosine, you already got a cosine there. If you add your powers, it'll look like this here. It'll look like sine of x, and then cosine times cosine would be cosine squared of x. Down in the denominator, we'll just write this as cosine x, and then over 1 minus sine of x. We'll keep it factored like that. In the numerator, we're going to need to FOIL these together here. I'm going to go ahead and do this now. Now, these are what's called conjugates here. And when you FOIL together conjugates, things cancel out here. I'm not going to write this, so just kind of think of this here for a second. 1 times 1 is 1. 1 times negative sine x is negative sine x, and 1 times positive sine x is positive sine x. Those terms would cancel out, and then you'd have the negative sine x times the sine x. So the two middle terms wind up canceling. So when you have a conjugate, here's kind of a shortcut that you can do. These are when the signs are just different. That's the only thing that's different between them. Just 1 times 1, which is 1, and then sine x times negative sine x is negative sine squared x. And then your denominator will be the same thing that we just had earlier, cosine x, and then 1 minus sine x. Okay. Now look up there in the red. Anything we can do there with the top right there? Since it's 1 minus sine squared x.
Get rid of one of the just turn it into cosine.
I like that idea. Did y'all hear that? Turn it into a cosine squared. That's actually a Pythagorean identity. Good thinking there. Start training your eye. If you see 1 and then a trig function squared, try to use a Pythagorean identity. We can change that to cosine squared of x. Does everyone agree with that? So the same right there. Okay, I'm going to go ahead and rewrite this as one single fraction now. I'm going to go cosine x and then 1 minus sine of x like that. And then I'll drop down the sine x and the cosine squared x. Now this is kind of like the last problem that we saw, that both of these terms in the numerator both have a what? They both have a, not just a cosine what? They both have a cosine squared, yeah. So what we're going to do there is factor out a cosine squared. We're going to undistribute. Right? If I factor out that cosine square, what would you be left with? Sine of x, good, minus 1. It was so close to actually being very similar to the one down below. There is some manipulation we can do here. See how those are the same binomials, so just reversed? Do y'all remember what we did earlier to reverse the order? Say what now?
Switch it, keep the signs.
Yeah, like kind of switch the order, keep the, and then change. It changes the signs, and the big idea is factoring out the negative. So, like for example, Here, I'll do it in the denominator. If you divide both of them by a negative, like a -1, it would look like this. It'd be sine of x and then +1 in that denominator. And then the numerator will still have all this stuff here. Cosine squared x, sine x -1 right there. Now, in the denominator, it's cosine x and then times -1. So the sine x plus 1 binomials cancel. And then you're left with this, and we're real close to done. I'm going to write as negative cosine x. What would happen now that you have cosine squared over cosine? What happens to the cosines? They can cancel. And this comes out to negative and then cosine of x. There you go. Let me kind of zoom out there. Big step was the Pythagorean identity step right there. It's like almost been used in almost every problem. All right. Okay, so with number 7, pay attention to the instructions here. Rewrite this to where it does not involve a fraction. Actually, so if you look at this problem, when we work it out, it actually doesn't simplify too much. That's why the instructions don't say simplify. They just say make it to where it's not a fraction. All right, we're going to start this problem here just like this, where to make or manipulate the bottom here of this to make it where it's not a fraction eventually. Can't do much with it when it's 1 plus cosine, but I'm going to manipulate this by multiplying the top and bottom by the conjugate. And what do I need to change for the conjugate to be the conjugate?
Minus.
Yeah, make it a minus there. So we're going to multiply by 1 minus cosine x on the top and bottom right there. Okay. Down in the denominator, number 7 here. Down in the denominator, since these are conjugates, we can use our new shortcut. That's going to be 1 minus cosine squared of x. In the numerator, I would technically need to distribute up here. So I guess I'll write that as 1 minus cosine of x. And what can we change 1 minus cosine squared to? We can use a Pythagorean identity to change that to sine squared in the bottom. Now you can only do this when you have one single piece, not like a binomial, but a single piece in the denominator here. And a lot of people will skip writing this step out, so I'll kind of write it in a different color here for a second. I'm going to rewrite 1 minus cosine of x over 1, and then times, and then I'm going to put 1 over sine squared of x. I'm kind of like splitting it apart there. A lot of people will skip that. And what can we change 1 minus sine squared to? Using a reciprocal identity. Oh, I heard it, cosecant. So we're going to change that to cosecant squared of x. And then that numerator from the other one will be 1 minus cosine of x right there. And that right there is basically a simplified. You could do a few more things. You could distribute and kind of clean up a few more things. But they didn't say to fully simplify. They said to just make it to where it's not a fraction. And that's how you do it right there. So from here to here is kind of the big crucial step right there that you kind of need to know right there. So we take that sine squared and we do a reciprocal identity to bring it up to the numerator. And you rewrite it as cosecant squared. Okay, so I put a star next to that step there. If you want to write the step, we're doing a reciprocal identity there. So look out there for that. Now, coming up here, 8 and 9, they're just more simplifying problems. Hopefully, I think some of y'all are starting to kind of get some of these down here. So let me ask you guys, any ideas on the first step here?
We replace the bottom.
Replace the bottom. I think that's a good idea. What could you replace the denominator with? That's a Pythagorean identity. So we could change that right there to sine squared. I agree. Oh, and I guess they have x. You know, you could, if you did theta, I don't think I'd count off. But so yeah, let's change that there. Some of y'all might say like maybe distribute or maybe go get a common denominator. I'd actually avoid that till the end because you can actually clean that fraction up a little bit more here. So don't actually distribute. What could you do with the signs? So what? It's already kind of been factored, but I heard it. What?
Cancel.
You can actually cancel. Yeah, it's already, the sign's already been factored, but you can cancel a couple of signs out right there and rewrite that as 1 plus sine of x, and then over just one single sine of x there. Now from here, we got a fraction with a whole number. We're going to have to combine the fractions, unfortunately. To get the fractions combined, we need to multiply, or I'm sorry, we need to get a what? Common denominator. What is a common denominator? Ooh, okay. And then also with this here, if you see a minus in between the fractions, write it as a plus and drag that negative to the numerator. Sometimes when you have a binomial, it won't happen in this case, but if you have a binomial in the numerator, you would need to distribute the negative. And that doesn't happen here in this case, but do it like that right there. So think about this. Now that you got a common denominator, we got 1 plus sine of x minus sine of x, and then all over sine of x here. Now, since the positive sine x and the negative sine x right here, since those don't, like this sine x is not being multiplied by anything, what can actually happen to the two sine x's up there? They can actually combine and cancel out, which means you're left with just what in the numerator? And what is 1 over sine x the same as? Cosecant x. There you go. Yes.
January 9th at 9:41.
I don't know. Yeah, it's obviously not right. All right, any follow-up questions there? Hopefully some of these are kind of, at least like, my goal for you, you might not be able to do every single problem on the homework, but my goal for you is to hopefully at least be able to follow the steps that I'm doing. Like, okay, how did I get from this step to this step? And, if you could do that, then like the Quizlet website or, your other solutions, your partner solutions, you might be able to track what they're doing that way there. So we'll finish up here with this one. We're almost done. With this one here, to add or subtract fractions, you need a common what? And actually, what do y'all notice about these denominators? They're actually conjugates. So when you do these here, the conjugates are going to actually clean each other up pretty well here. So yeah, multiply and by 1 minus sine x on the top and bottom of the first fraction, and 1 plus sine x on the top and bottom of the second fraction. In the denominators, I'm going to go ahead and simplify. Since they're conjugates, they should clean up here for a while. What would you get when you FOIL those together? 1 minus sine squared of x. That's actually going to happen for both fractions. Oops. In the numerator, go ahead and distribute cosine to both sine of x and negative 1, or a positive 1, I guess. Let's come out to cosine x minus sine x times cosine x. In the numerator over here, distribute there. And it looks like it's going to be a mess. I promise it'll clean up real nice here. This will be cosine x, and I'm going to rewrite it instead of cosine times sine. I'm going to write it as sine x times cosine x, so it's kind of in the same order. Now, because of that, when you combine up the numerators, something's going to cancel, actually. What might cancel here?
Sine of x times cosine of x.
Yep, the sine of x times cosine x, one of them is positive and one of them is negative. So since those are like terms, they would cancel. How many cosines would you have? How would you write it? Okay, yeah, so some of y'all might think 2 cosines, some of y'all might think cosine squared. We're not multiplying, so we're not going to add the powers. So this will actually be 2 cosine x like that. Down in the denominator, you could change that to cosine squared. Good. Yep, with a Pythagorean identity. And then we're almost done here. Cosine over cosine squared. What would happen with these? You'd cancel it out. 2 over cosine. And then let's do a reciprocal identity so we don't write this as a fraction. So 2 what? What's the reciprocal of cosine? Secant. Good. And then you do secant x. All right. Anyways, that is it.
I got it.
All right, y'all's brains hurting yet? All right, so on this last problem here, number 10, some people might think to change this in terms of sine and cosine. We're actually not going to do that here. On this one, we're going to, since both of these terms have cotangent, we will factor out a cotangent x. Okay, when we undistribute a cotangent x, we'll be left with 1 and then minus cosecant squared x, like that. So we are factoring out a cotangent. Now, since 1 minus cosecant squared of x, that's actually one of your Pythagorean identities, but it is unfortunately in the wrong order, so we do need to kind of change the way it looks here. So let me find that here. So yeah, right here, if we swap that order there, or move those to the other side to where it's positive 1 and negative cosecant squared, we need to move the cotangent squared to the other side, and therefore it would equal negative cotangent squared. So it's just because it's in a weird order that this thing here will simplify down to negative cotangent squared. Now that we have negative cotangent squared times cotangent of x, we'll just add the powers, cotangent cubed of x, and then drop down the negative. And then that'll be it right there.